Friction. There are many different types of forces that occur in nature, but perhaps none is more familiar to us than the force of friction, F sub F. Friction is a reaction force that opposes the motion of an object. When sandpaper is pushed against rough wood, the friction force smooths out the wood's surface. Newton's third law explains that the rough wood is pushing against the sandpaper with a friction force, action-reaction pair of forces, removing its rough edges. Friction is the reason objects stop from sliding along a surface. It's the reason it's difficult to start pushing a heavy box along the floor. There are many different types of friction. Friction between solid objects and air is air resistance. Friction between two fluids is viscosity. Rolling friction occurs between a tire on a moving car and the road. This unit will deal only with kinetic and static friction. Where does friction come from? On a microscopic scale, most surfaces are rough. This leads to complex interactions between them that won't be considered now, but the force can be modeled in a simple way. Friction that acts on an object that is already in motion is called kinetic friction. For kinetic or sliding friction, the equation is the force of friction equals mu sub k times the normal force. Kinetic friction is the product of two things. Mu sub k is the coefficient of kinetic friction and is different for every pair of surfaces. F sub n is the normal force, which on flat surfaces that are not accelerating is equal to the weight of the object. A larger coefficient of friction means a greater frictional force. It's a property of the two materials that are involved. An object by itself does not have a unique coefficient of friction. Generally, the coefficient of friction is a number between 0 and 1, and the higher it is, the more friction. So, for example, human joints in limbs have a very low coefficient of friction, 0.01, whereas rubber on dry concrete has a high kinetic friction coefficient of 0.7. A person accelerates a crate along a rough surface. Draw the crate's free body diagram and find the sum of the forces in the x and y directions. All right, so here's a free body diagram showing acceleration. Note how force applied has been drawn so that it is longer than the vector for force of friction, showing there is an unbalanced force to the right, therefore an acceleration to the right. In the y dimension, these forces are opposite and equal, since our object is not accelerating up or down. Let's find the sum of the forces in the x and y directions. We're going to use Newton's second law separately for each dimension. So here we have the sum of the forces in the x dimension equals ma in the x direction, and over here we have the y dimension. So here, sum up the forces in the x, well, let's say to the right is positive. We're mostly going to say that the direction of acceleration will be positive. So F applied is positive, minus the force of friction, since it's going in the opposite direction, equals ma. And over here, there's no acceleration up or down, therefore the right side of the equation is 0. Force normal is positive, weight is negative, therefore they are equal. The coefficient of kinetic friction between an object and the horizontal surface upon which it is sliding is 0.4. The mass of the object is 3.2 kilograms. What is the force of friction? All right, over here we list our givens, and we're going to use our friction equation. The normal force will be equal to the object's weight because we're simply on a horizontal surface. So therefore, instead of Fn, we're going to put in mg right here. So mu times m times g gives us a frictional force of 12.5 newtons. A 10 kilogram block is being pushed across a horizontal floor with a force of 60 newtons, accelerating at a rate of 0.4 meters per second squared. What is the coefficient of friction between the floor and the crate? All right, our first step is to use Newton's second law in the vertical dimension to find the normal force. So here, there's no acceleration up or down, so the right side of the equation is 0. Therefore, the normal force is equal to mg. Then we use the friction equation to find the frictional force, which is reliant on the normal force. That's why we found that first. The frictional force is mu times the normal force, mg, mu mg. Finally, we use Newton's second law in the horizontal direction. So to the right, we have force applied. To the left, we have the frictional force, which is why it's negative. Set it equal to ma. Take the frictional force, plug it in here, and we get this formula here. All right, this is where we left off on the last slide. Then we're going to solve this algebraically for mu. So first we can take that term, put it on that side. We'll take that term, put it on that side. We'll divide both sides by mg, and we get this expression here. Then we can plug our numbers in, and we get 0.6 for mu. There are no units. Mu is just a ratio, so it's just a number with no units, and it's generally between 0 and 1. Static friction is the frictional force between two surfaces that are not moving along each other. Static friction keeps objects from moving when a force is first applied. Unlike kinetic friction, static friction is not a constant force. It exerts only as much force to be equal and opposite to the applied force, until the static friction reaches a maximum value, and then, as the applied force increases, the object accelerates in the direction of the applied force, and the friction will switch from static to kinetic. The static friction force is represented as an inequality to fit this phenomenon, where mu sub s is the coefficient of static friction and is different for every pair of surfaces. More on the inequality symbol in this equation. Imagine pushing on a box until it moves. You can apply a small force. Nothing happens. You apply more and more force until the box finally starts moving. This is the maximum amount of static friction. The static friction can be less than the maximum amount or equal to its maximum amount, but never greater. The force of friction is equal to the maximum static friction force, mu s Fn, at the instant when the object starts to move. Then what happens? The static friction force increases as the applied force increases, always equal to the net applied force. So you push with 10 newtons, there's 10 newtons of frictional force. The object's not moving. You push with 20 newtons, then 20 newtons of friction matches you, static friction. Still not moving, all the way up till we get to 40 here. That's when it reaches its maximum value, mu sub s Fn. Then the object starts to move, and the kinetic friction force takes over. So look, right when it starts to move, it drops down, and it turns into kinetic friction, which is constant, no matter how hard you push. The kinetic friction force here is less than the maximum static friction force up here, which could catch the person applying the force unaware with a rapid, unexpected acceleration. It's harder to get something to start moving than to keep it moving. This table shows both the static and kinetic coefficients of friction. Most of the time, the coefficient of kinetic friction is less than the coefficient of static friction. Not always, but most of the time. Here you can see they're equal. Here, rubber on dry concrete, kinetic friction is 0.8, static friction is 1. Some race car tires are engineered to go above 1 so that they can turn corners really fast without sliding. A 5-kilogram block is sitting on a table. The coefficient of static friction between the surfaces is 0.7. What is the largest force that can be applied horizontally to the block before it begins to slide? First, we list our givens. Now we have an equation. That inequality becomes an equal sign, and that will give us the maximum static friction force as long as we put the coefficient of static friction in that equation. The normal force is equal to the object's weight since we're just on a horizontal surface. Combine those two formulas. The object will only start to move when the applied force is greater than the maximum static friction force. So the maximum static friction force is 34.3 newtons. An applied force greater than this will cause the block to slide. A 6-kilogram block is sitting on a table. The coefficient of static friction between the surfaces is 0.6. If a 10-newton horizontal force is applied to the block, what will be the force of friction? First, calculate the maximum static friction force. We use our equation for friction, set that inequality to an equal, then our normal force will be mg since we're on a horizontal surface. Plug in our numbers and we get a maximum static friction force of 35.3 newtons. The applied force in this problem is 10 newtons, which is less than 35.3 newtons. The static friction force will match any applied force that is less than 35.3 newtons. Therefore, the force of friction will be 10 newtons. The sum of the applied force and the friction force is 0. The block will not move.